All right, guys, today we are covering lesson 112, which is about graphing equations of lines and circles. So go ahead and grab out your notes. As always, feel free to pause the video, speed it up, rewind, all of that jazz. Okay, so I'm going to have you guys write down, as always, what the objective is for today, and then you can pause the video. Please attempt these warm-up problems on your own, and then unpause it, come back, look at the solutions that I posted, and see if yours are correct. Okay, so here this says, write each equation so that y is a function of x. What that means is we want to end up with some equation where y is our variable that's isolated or solved for on the left side, and then we have some function involving x on the right side. Okay, so we're just going to look at this first one and try to isolate or get y by itself. So that would mean I would need to subtract the 6x from both sides. Then I get 4y equals negative 6x plus 16. And to get rid of this 4, or to move it to the other side, I divide every single term by it. So then I get y equals negative 6/4. Well, those two numbers are both divisible by 2. So negative 6 divided by 2 is 3. And then 4 divided by 2 is 2. So negative 3/2 x plus 16 divided by 4 is 4. And voila, we have a function y of the variable x. Okay, the next one here, we're going to subtract x from both sides. To isolate this 2y, we get 2y equals negative x plus 5. Then we're going to divide every single term by 2. And I'm just going to write in here that this is the same thing as negative 1x. So if you have a negative x, that's the same thing as negative 1x, or negative 1/2 when you divide by 2. Negative 1/2 x plus 5/2. And we're just going to keep everything as a fraction for right now. Okay, and then last but not least, same thing here. We would isolate the 6y, add 12x to both sides. We'd get 6y equals 12x minus 12. And then we would divide every single term by 6. So we'd get y equals 2x minus 2. So this is in prep of today when we're going to talk about equations of lines and graphing those lines, because all three of these are equations of lines. They're actually written in a form you guys might recognize as y equals mx plus b form or slope-intercept form. You do not have to remember that for right now. So these are just those solutions that we found. Okay, graphing an equation using a table. So this is something we're going to do all year long. And just to review this could be with any type of function we're talking about, not just linear, but just to review how to graph an equation using a table. Oftentimes, the first thing that you're going to want to do, step 1 here, is to solve the equation for y. So in this case, if it's not already solved for y, you want to isolate y like we just did in our warm-up, because we always graph equations in that format. Okay, step 2, you're going to make a t-table by choosing a couple values for x and y. So when I say a t-table, what I'm saying is this table, t-table, or input-output table, where you have x for your input and y for your outputs. And then you're just going to choose a couple numbers for x, okay, to plug in to the equation and get what your y values would be. Step 3, you're going to plot the points that you have in your table. Okay, and then step 4, you're going to connect the points. So let's go ahead and go through this process for this specific example here, negative 2x plus y equals negative 3. So I've written that here. We're going to graph this using a table, going through the steps step by step. So first thing we're going to do is solve the equation for y. So we have negative 2x plus y equals negative 3. So to isolate y, I want to add the 2x to both sides. And then I get y equals 2x minus 3. Okay, so that's the first step is done. Then I'm going to make my t-table or my xy table. And typically when you're dealing with especially a linear function like this or a line, you can choose values of x that kind of revolve around 0. So I would have 0 in the middle and then choose a couple negative numbers and a couple positive numbers. So let's just say we choose -2, -1, 0, 1, and 2. That should give us a good idea. Having 4 to 5 points should give us a good idea of what the shape's going to look like. So I'm going to plug in every single one of these x values for x in the equation here. Okay, so over to the side, I'll show that work. If we're going to plug in -2 to start with, I would have y equals 2 times, now instead of x, I'd have times -2, and I'm going to put it in parentheses -3. 2 times -2 is -4, and then -3 is -7. Okay, and then same thing for -1. So 2 times now -1 minus 3. 2 times -1 is -2. And then -2 minus 3 is -5. Remember, when you're subtracting a negative from another negative, it makes a bigger negative. Okay, then let's plug in 0. So 2 times 0 minus 3. Well, anything times 0 is just 0. 0 minus 3 is -3. Okay, then we'll plug in 1 and 2. And this is something you can obviously have your calculator help you with as well. I would just caution you to be really careful anytime you're plugging in values to a calculator, not to plug in the entire thing, because it's going to be easy to make a mistake there. Okay, and then steps 3 and 4, you're going to plot the points and connect them. So -2, -7, we've got x here, y here, -2 is over here, -1, 2, 3, 4, 5, 6, 7, put a point. -1, comma, -5, 0, comma, -3, oopsies, I miscounted. 1, 2, 3, 4, 5, 6, 7, here we go, there we go. Okay, 1, -1, and then 2, comma, 1. All right, and then we're going to connect those points. So again, this gives us a great idea of the shape and the general placement of the line. So that is as easy as it is. Okay, here's the solution again. This just shows you a nice, neat graph. All right, next thing we're going to talk about today is how do you find the intercepts of an equation and then graph from that. So the x-intercept on any graph is a point that intersects the x-axis. So it's exactly like it sounds like. Think of an interception in football, okay? That is where the x-axis is intercepting the equation or the function. So in order to solve for the x-intercept, if we think about a coordinate plane where we've got our x and our y axes, an x-coordinate is anywhere along the x-axis, okay? Any point that is going to cross or intersect this x-axis. Well, what is y equal to all along this x-axis? Y is equal to 0. So we're going to substitute 0 in for x. Okay, and then similarly, a y-intercept is a point that intersects the y-axis. And so since it's any point on this axis, y can be anything, but if you look, x right here along this entire axis is equal to 0. So you would set x equal to 0 and then solve. Okay, so to find an x or y intercept, you always set the opposite variable equal to 0. So set opposite variable equal to 0. Okay, so here is our example. I have it on the next page for us as well. We're going to find the two intercepts of this equation, 2x plus 7y equals 28. So for the x-intercept, again, we're going to set y equal to 0 and solve for x. So I've got 2x plus 7 times 0 now. Y is going to become 0 equals 28. And again, another thing or another way to remember this is if you're finding an x-intercept, you should have x in the equation still. So you should be able to solve for x. Okay, so anything times 0 is 0. And then 2x plus 0 is just 2x. So we have 2x equals 28. Divide by 2. And then we get x equals 14. But remember, this is a point. This is not a single value. So our final answer would be the point 14, comma 0, because when x is 14, y is 0. Okay, so that is our final answer for that one. All right, next let's find the y-intercept. So this time we're setting x in the equation up here equal to 0. So we have 2 times 0 plus 7y equals 28. Again, we should still have a y in there because we're going to want to solve for that variable. So that gives me 0 plus 7y equals 28. 0 plus 7y is just 7y equals 28. Divide both sides by 7, you get y equals 14. Hey, happens to be the same one. Awesome. Okay, and then your answer here now is 0, comma 14 because x is 0 and y is 14. Okay, so again, just write it as a coordinate point for your last step. Oh, and here, I made a mistake. This should be 0, comma 4. What am I thinking? 28 divided by 7 is not 14. My brain. So 0, comma 4. Hopefully you guys caught that mistake. Okay, using intercepts to graph. So this is a quick way to graph a function or most shapes. So step 1, if you're trying to graph just by using the x-intercepts, find the x-intercept. Step 2, find the y-intercept. Step 3, plot the 2 points. And step 4, if we're talking specifically about a line, you're going to draw a line through those 2 points. Okay. Step 5, you're then going to name the line or label it. So we've got this example. Again, I've got it written on the next page for us. So we're going to graph x plus 2y equals 4 using the intercepts. So the first step, I'm going to find the x-intercept. So I still need an x. Okay, and I'm going to set y in the equation equal to 0. So plus 2 times 0 equals 4. So then 2 times 0 is just 0. So we just get x plus 0 equals 4, which is just x equals 4. Okay, so x equals 4 and y equals 0. So that's that point. Next step, let's find the y-intercept. So this time we're going to set x equal to 0. So we get 0 plus 2y equals 4. 0 plus 2y is just 2y divided by 2. Y equals 2. And so then we know that x was equal to 0, y was equal to 2, so that's our point. All right, then steps 3, 4, and 5 say plot those 2 points, draw a line between them, and label the line. So 4, comma 0, we're going to go 4 over 1, 2, 3, 4 in the x direction. 0, comma 2, up 2 in the y direction. Then we will draw a line between them. Oh, that's a little bit off. There we go. Okay, it's a little bit better. And voila, there is our line. So this is a little bit easier than having to go through the process of creating a full table because the x and y intercepts will give us 2 points and all you need to draw a line are 2 points. Okay, there again are the answers. All right, and then the last thing we're going to do today is talk about the equation of a circle. So here is the standard form of the equation of a circle. Looks scary, but I promise it's not bad once you get used to it. So we've got x minus h squared plus y minus k squared equals r squared. Let me explain what these variables stand for. So h and k make up the coordinates of the center of the circle. Okay, so h comma k is the center of the circle. Now notice this is a minus sign and a minus sign. So h and k are always going to be opposite signs of what is in the equation. X and y are just the variables, and then r is the radius of the circle. So if you remember when we've got a circle, let's just pretend that this is a perfect circle. The radius of the circle is the distance between the center, so I'm going to call this C for center, and the outside of the circle at any given point. So the radius is always going to be the same length, okay? It's that distance between the middle of the circle and the outside. Okay, so let's look at this example. We've got x minus 4 squared plus y plus 1 squared equals 9. So if I look and identify h is positive 4, so opposite sign because it's a minus right there. And then k is not positive 1, but it's a negative 1 because it's opposite sign. Okay, so we've got h comma k is 4 comma negative 1, so that's the center, and then the radius squared is on the outside. Now, if 9 is r squared, and you want to just know what is r, what's the radius by itself? Well, how do you undo squaring something? Well, the opposite of squaring something is to square root it. And so that means when you take the square root, r, or the radius, would be 3. So you're always going to take the square root of this outside term, or r squared, to get whatever the radius is. Okay, so let's do some examples here. And before we do that, we'll just go through the steps really quickly on how to graph circles from their equation. So step 1, identify the center. Step 2, identify the radius. Step 3, plot the points. And then step 4, sketch and connect the graph. Okay, so here's our first example. Graph the circle x squared plus y squared equals 9. So we're going to identify the center. Now this one's a little bit weird because if you notice, x is not subtracting anything. This would be the same thing as saying x minus 0 squared plus y minus 0 squared. So neither x or y are subtracting anything, which is the same thing as subtracting 0, okay? So when you see that it's not subtracting or adding anything, the center is actually going to be at 0, 0. So the center is 0, 0. Now we're going to identify the radius. So the outside here, 9 is r squared. We just had that example with square root. And you don't really have to set it up like that. You can just take the square root of 9, okay? Once you get used to that, which is 3. So the radius equals 3. I'm going to write that as r equals 3. And then also here for the center, you can write c. Center is 0, 0. Okay, then we're going to plot those points and we're going to sketch the graph. So I'm going to plot the center point at 0, 0. I'll color coordinate this for us. And then if the radius is 3 units away, that means I'm going to go 3 units in every single direction from the center. So up, down, right, left. So up 3, to the right 3, down 3, to the left 3. Okay, in every single direction. And then I'm going to try to connect these points as best as I can. Let's just pretend that those go through perfectly. That is my circle. All right, so there again is that nice, neat graph. One more example for us, graphing circle from a description. So write and graph the equation of a circle centered at -2, 3 with a radius at 2. So if the general form is this, I'm going to plug this in for h, comma, k. Okay, so x minus a -2 plus y minus 3 squared equals radius of 2 squared. Minus a negative is the same thing as a positive. Okay, that double negative becomes positive. So this is x plus 2 squared plus quantity y minus 3 squared equals 2 squared is then 4. So here's the equation of this circle. And then if I were to draw this, this is going to be a little bit tiny, a little bit harder to see. So -1, 2, 1, 2, 3 is where my center of this circle is, and then we've got a radius of 2 in each direction. Okay, so then from here, oopsies, I forgot to put 2 more unit marks up there. We're going to go up 2, to the left 2, to the right 2, down 2, and connect the circle. All right, so here's your homework. You're going to practice these couple of concepts. Go ahead and pause the video. You can write this down. It's also written on Google Classroom. And then these pages, again, they're going to be connected. They're in the 1-1 book problems. I'll show you here in a second. So that's what this looks like. Okay, remember, you are never going to be doing these warm-up problems at the top. So you're always starting with the exercises, wherever those are. So we're starting with number 25. So you'll scroll down, start here at number 25, and then you'll go on to the next couple pages for the next few problems.